Hey guys, it's Mrs. Roderick. Sorry, Trevor, I don't have a joke right now ready. Next time. Uh, so today in class, you copied this page down talking about Newton's first law of motion. He has three laws, and the first law is also just known as the law of inertia. Remember, an object at rest will stay at rest, and an object in motion will stay in motion at the same speed and direction unless an unbalanced force acts on it. Remember, we took our bus ride, we talked about why we wear seat belts. I did my couple demos, so really keep in mind what does Newton's law first mean? It's that law of inertia. So think of all those demos we did in class today that you got to see. Then we talked about Newton's second law of motion, and it can be simplified by just saying acceleration equals force divided by mass. And again, it's pretty common sense that, if I kick a ball with a much bigger force, it's going to accelerate more. So if I have a big force, it's going to have a big acceleration. That's what they mean by directly proportional. And then your mass and acceleration, we talked about the fact that I could throw a baseball, which has a small mass. I can make that accelerate much more than if I had a big mass like a shot put or a bowling ball, it's going to accelerate less. So mass and acceleration are inversely proportional if your force stays the same. So really kind of take a second to digest that and make sure that you can do it. So what I want to do now is go over these problems a little bit. As always, and you guys have gotten so good at this, you want to list your knowns and unknowns when you read the word problem. Let your units help you out with what they are and really read the words. Then make sure you write the right formula. The formulas we're going to use today are either going to be F equals M times A, M equals F divided by A, or A equals F divided by M. And we'll also throw weight in there too. So I am going to give you a few new notes today, so stick with me for just a few minutes. Obviously, then you're always going to substitute your numbers and your units into your formula, then calculate, round to those proper significant figures. Again, just make sure you don't have too many. Try to have whichever has the fewest is what you want to round down to. And then make sure you have those proper final units, which becomes pretty tricky here. For force, which we're going to talk about today, we're also going to talk about weight, which is just a specific force. It's the force of gravity acting on an object. The units are newtons, okay? So your final answer will always be in newtons. What you need to know is that a newton is the same thing as a kilogram times a meter per second squared, or a meter per second per second. Sometimes when these last two units in acceleration are the same, they write it like this, meters per second squared. Either way is fine. They mean the same thing. Your mass always has to be in kilograms. All right. So let's go ahead. And this next thing I want to give you is our mass. So if you haven't filled these blanks in, this is on 23E in your binder. So make sure you flip there and fill in all these blanks. And these other blanks have been on 23D. So mass is a measure of the inertia in an object, and it depends on the amount of matter in an object. So we talked about if I'm an astronaut and I'm going into outer space, my mass isn't going to change unless I lose an arm on the trip up there. The matter that I'm made up of is the same. Whereas my weight is going to change, like with what we looked at comparing that box falling on Jupiter or Earth or Mars. It changes because the acceleration due to gravity is different. But just think of weight as a specific force, all right? So we know force is mass times gravity. So weight, which is a specific force, is mass times a specific acceleration. It's the acceleration due to gravity. So force is mass times acceleration. Weight is mass times gravity. So they're really the same formula, just weight is more specific. We already talked about the fact that acceleration is inversely proportional to mass if you apply the same force. And weight is the force of gravity acting on an object. Weight equals mass times the acceleration due to gravity, which we use g. And the acceleration due to gravity on Earth, we already did a bunch of gravity problems, is 9.8 meters per second squared, or meters per second per second. So you're going to have to use that probably more tomorrow. We're not going to see problems with that today just yet, but I want to have you all geared up for tomorrow. All right, so now I want you to take a second and get out either a clean sheet of paper, or in your binder, if you flip to the back side of 23I, if you didn't write on it too much, we're going to do two problems together. So clean sheet of paper, get it out, or the back of 23I where you can write this problem down. All right, so What force, ding, 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 what force, that's my unknown, okay, will cause a 45 kilogram object? Now, it doesn't say what it is, but I know that kilograms measure mass. I hope you're all shouting that out at home. All right, so 45 kilograms is my mass, and then it says causes this object to accelerate at 2.300 meters per second. So that is my acceleration, my 2.300 meters per second per second. Okay, the next thing I'm going to do is write my formula. F equals mass times acceleration. All right. Then I'm going to substitute in my numbers. My mass is right here, 45.00 kilograms. And I'm multiplying that by my acceleration. That's my A. I'm just substituting in my numbers there. 2.300 meters per second per second. I'm running out of room here. And when I multiply those, I will get 103.5. Now I have kilograms times meters per second per second. And if you look back in your notes, you remember from before, I told you guys that a kilogram times a meter per second, oops, is, where is it? Okay, sorry, is right here, is the same thing as a Newton. So for your final answer, you're going to use Newtons, and I'll show you in a second how you're going to use this in a problem when you are there. So we'll flip back here. So instead of kilograms per meter per second, or sorry, kilograms times meters per second, we're going to write 103.5 newtons. So that's your final answer. Okay, you don't want to leave it like this. You want to write it, that is a Newton. All right, so I listed my knowns and unknowns. I wrote my formula. I substituted in my numbers and my units. I got the right answer, rounded it to the right sig figs. There were 4 here, 4 here, 4 there, and I had my right final units. So hopefully you guys are good with that. Pause it if you didn't copy it all down and get that. Next problem is what mass object will accelerate, yada, yada, yada. So what mass, so that's my unknown, mass equals question mark, will accelerate at 3.400 meters per second. Again, will accelerate at, plus your units of meters per second should be a good clue. So my acceleration is 3.40 meters per second per second. If I give it a 10.0 Newton push. Now it doesn't say what it is, but we know that Newtons measure force, and they say it's a push. So that's my force. So my formula for mass, let's take a second because we didn't go through these. Let me just take 1 second. If F equals M times A, a little algebra lesson. You know I like my algebra. What the heck? Something's going on. Okay, hopefully I'm okay. Sorry about that. If F equals M times A and I want to solve for M, I'm going to get rid of my A by dividing by A. That'll get rid of it. Anything I do to one side, I do to the other. So M would equal F divided by A. And if F equals M times A, then, and I want to solve for A, I divide by M, cancel those out, and I have A equals F over M. Okay? So that's where I got these formulas from. Again, hopefully your algebra is good enough that you can do that. If not, I understand. All right, so M equals, we just said F over A. So we're going to plug in our numbers. So this is where I was saying, instead of writing 10 newtons, I'm going to write 10.0 newtons. I'm going to write what a newton is equal to, which is a kilogram times a meter per second per second. All right. The reason I'm going to do that is then when I substitute my A on the bottom, my 3.40 meters per second, when I divide those, mathematically, I'm going to get 2.94, but I can see I have meters per second on top, meters per second on bottom, per second on bottom, so those are going to cancel out, and I'm left with kilograms. And just ask yourself, do kilograms make sense for mass? Yeah, they totally do. So again, I listed my knowns and unknowns, I wrote my formula, I plugged in numbers and units, I got the right answer, right sig figs, right final units. What I want you guys to do now is complete those binder pages. or the binder page 34. There's only a couple there. The information on top will be really, really helpful for you. And also, for those of you that are listening, do number 1 on page 25. All right. I'll see you guys tomorrow. Sorry about my slip up there. Didn't feel like re-recording it all. All right. Catch you later. Bye.